So for the first one, to find the inverse, we swap x and y because we're interchanging input and output. Then we need to isolate y right here, so we subtract 10, and then we would divide by 3, and then we take the cube root of both sides, odd index, so no plus or minus. So our inverse is cube root of x minus 10 over 3. For the next one, you want to do the same thing, so we interchange the input and output. We want to isolate y to the 7th, so we multiply by the reciprocal, negative 8 over 3. So on the right side, negative 3/8 cancels. On the left side, we get negative 8 thirds times x. To undo 7th power, we take the 7th root, because on index, no plus or minus. So here's our answer, our inverse equation. For this one, I would just look at the equation that looks easier to work with. So I'm going to work with the left one. I'm going to interchange x and y. I'll isolate y cubed, take the cube root. So then our inverse equation is cube root of x over 6. Okay, so for this equation, you first need to find the critical point, 0, 8. So remember what I said, when we have the x under the radical, we're going to set what's under equal to 0. So the x coordinate of the critical point is 0, and then our y is the number on the right side of that radical, so 8. So that's our critical value. Since it's a cube root, we want to put it in the center of our table. You can pick any x value on either side of 0. So I plug in 8 and negative 8. And when I plug in 8, you have to do order of operations. So the cube root of 8 is 2. Then you multiply. So 2 times a half is 1. And then 1 plus 8 is 9. So in went 8, out comes 9. So our ordered pair is 8, 9. Then when you plug in negative 8, same thing. Cube root of negative 8 is negative 2. You multiply by a half, you get negative 1. Add 8, you get 7. So we have our ordered pairs. Here's our critical point in the center. And we draw a rough sketch. Domain and range are going to be all reals. And in terms of transformations, it's going to be a vertical shrink. Absolute value of half is less than 1. And we look at our critical point, and the y-coordinate is positive 8, meaning it goes up 8. Remember, you can always start and put your finger at the origin and say, what do I do to move to the new critical point? Well, if the new critical point is up here, if we're talking about in comparison to the parent function, we just went up. Again, critical point for this, if we look under radical, we have 4, 6, 4 square roots. That's going to start our table, because we have a plug-in number is greater than 4 for x. So then I picked 8 and 20. So when I plug in 8, g of 8, the 8 goes in for x. 8 minus 4 is 4. Square root of 4 is 2. The negative drops down. You're multiplying by negative 1, so you get negative 2 plus 6 is 4. So it's 8, 4. Then when you plug in 20, 20 minus 4 is 16. The square of 16 is 4. You multiply by negative 1, you get negative 4 plus 6 is 2. So we have 3 points. Critical point, important, it's going down this direction. So you got to be careful for square roots. Look at the domain and the range. Just look at the critical point. So if the critical point's 4, 6, the x value is 4. My graph, or my x values, are to the right of 4. So that's why x is greater or equal to 4. My y values are under 6. So you say y is less than or equal to 6. In terms of transformations, we see this negative right there. That means there's a reflection across the x-axis. If we look at the critical point, 4, 6, it shows us that the graph went to the right 4, up 6. You can always put your finger on the center and ask yourself, how do we get to the new critical point? And we went to the right 4 units, and we went up 6. Okay, so we see an index of 3, so we're going to cube both sides because we have one term. They're inverse operations, they cancel. So we have 7x minus 7 is equal to 3x minus 2. Easy equation to solve for, so get x on one side. So I chose to subtract 3x, so we get 4x minus 7 equals negative 2. So then we can add 7 to both sides. So we get 4x equals 5, divide by 4. So x is 5/4. So for this problem,
take that cake home.
we're going to isolate the parentheses. So we want to get rid of 1/2 first. So we'll multiply by the reciprocal. We multiply by 2 over 1. So on the right, we get 9. I'm going to now turn this part into radical form. So my index is a 3. And then underneath, I'm left with the parentheses 5x plus 7 raised to the second power. So you see I wrote that right here. Now focus on one thing at a time. In order to get rid of the radical, since it's a 3, I need to raise both sides to that power. So we raise both sides to the third power. So that cancels. Now I'm left with 5x plus 7 to the second. In order to get rid of a power 2, we need to apply radical with index 2. When you apply radical with an even index, you always have to write plus or minus. So we have 5x plus 7 equals plus or minus 27. You then have to isolate x. So you can subtract 7. So I did plus or minus 27 minus 7. We then divide by 5. So we need to look out for our two answers. It's positive 27 minus 7 over 5, which is 4. And it's negative 27 minus 7 over 5, which is negative 34 over 5. So then, for this last one, we need to square both sides because there's an expression on the left, plus or minus in between. We need to make sure that we FOIL. So we have x minus 4 times x minus 4. On the right, the radical is gone, so we're left with 8x minus 48. When we FOIL on the left, x times x squared minus 4x gets us minus 8x. Negative 4 times negative 4 is 16. Then we get all terms on one side, so we subtract 8x. We add 48. We end up with x squared minus 6x plus 64. You try to factor if you can. We get x minus 8, x minus 8. You set your factors equal to 0, and you get x equals 8. It's just a repeated solution. That's it.